Hi everybody! In this video, we will review special case solutions. Now all that means is we're just labeling the type of answer that we get when we solve an equation normally. We have the option of getting one solution, that's what we're used to. We can get infinite solutions or no solutions. So let's jump right into different examples of each one. Now the equations you're used to solving are equations that have one solution in the end. So here's an example. We have 2x minus 6 equals 18. Now we have to undo the operations that are there, so since the 6 is being subtracted, we can add 6 to both sides. Therefore these cancel and we're left with 2x equals 24. The 2 here is being multiplied with the x, so we're going to take each side and divide it by 2, making these simplify out and cancel, leaving us with x equals 12. That means that our equation has one solution. 12 is the only number that will make that equation true when we plug it in for x. Alright. So let's look at a problem where we'll end up with infinite solutions. Again, infinite solutions refers to the answer that we end up with at the end. So we have to do the problem first in order to discover that. So let's start it out. This negative 2 is being multiplied by the quantity j minus 3, telling us that we have to distribute. Negative 2 times j is negative 2j. Negative 2 times negative 3 is positive 6. And we didn't do anything with the right-hand side yet, so just bring it down. Alright, now I'm going to add 2j to both sides. Now you may be saying to yourself, oh wait, they're both going to cancel. And that's the special thing about problems that have infinite solutions. Let's complete it. Negative 2j plus 2j cancels out, leaving us with 6. And then this negative 2j plus 2j cancels as well, leaving us with 6. This is the type of answer you'll end up with when you have infinite solutions. You'll end up with a true statement, like 6 equals 6. Or 0 equals 0, or negative 3 equals negative 3. Something like that. And what that actually means is that you can plug in any number you want for j in the original problem, and it will give you a true statement. Moving on to one that will end up with no solution. Again, we start out solving it just like a regular equation. I notice here on the left-hand side I have like terms because the 10 has an x and the negative 3 has an x. So my first step is going to be to subtract these, leaving us with 7x equals 4 plus 7x. Okay. Now since this is 4 plus 7x, I can subtract 7x from both sides to make that cancel. 7x minus 7x is 0. 7x minus 7x again is 0, so we're left with 4 on the right-hand side. Now ask yourself, is 0 equals 4 a true statement? No, of course it's not. So that's why this one is no solution. What that actually means is that whatever number you plug in for x in the original equation, it's never going to leave you with a true statement. So your answer for no solution problems will be things that don't equal each other, like negative 1 equals 5, or like 10 equals 12, anything like that. So that's how you can tell. So in summary, You're not going to be told whether there's one solution, infinite solutions, or no solutions. You're going to have to, number one, solve the equation normally. And number two, look at what answer you get. If you get an answer that looks like x equals a number, for example, x equals 12, it's going to be one solution. If you get an answer that's a true statement, such as 4 equals 4, it's going to be infinite solutions. And if you end up with an answer that's an untrue statement, such as 7 equals negative 2, you're going to put no solution. Now, just one last thing I want to point out is that in the cases where it's infinite solutions or no solution, your answer does not have a variable. Whereas when there's one solution, we have a variable in our answer. And that's it. Good job!